Today's lesson is 6.3a, add and subtract rational expressions with unlike denominators. In the last lesson that we learned how to add and subtract our rational expressions when the denominators were the same. However, what's going to happen when the denominators are not the same? Well, when they're not the same, we have to find what is called the least common denominator, or the LCD, which is the least common multiple of our denominators. And if you take a look at our quick little poster over here, that's just a reminder of how to find the least common multiple, or the LCM. It is the least common multiple of two or more integers is the smallest positive multiple that they share. So take a look at our examples here. The multiples of 4 are negative 16, negative 12, negative 8, negative 4, 0, 4, 8, 12, 16, and so on. Notice it's continuing in both directions. And the reason they're showing you the negative is because sometimes if both numbers are negative, you need to look for the negative least common multiple. And then we have the multiples of 6. And we can see right here that their least common one is 12. Their least common one is 12. Another way that you can find the least common multiple is you can break 4 and 6 down into their prime factors. So 4 would be 2 times 2, and 6 would be 2 times 3. Primes would be 2, 3, 5, 7, 11, 13. Those are going to be your common ones that you see. To take your least common multiple, you need to take the number that they share, which is the 2, and that one only comes once. And then you take the 2 from the 4, and you take the 3 from the 6, and 2 times 2 is 4, and 4 times 3 is 12. And that's another way to go ahead and get 12. If you have variables in your denominator for your least common denominator, for your least common multiple, then you're going to take the biggest the biggest exponent you see on your variables. So if we had 4x and 6x squared, I would still have my least common multiple of 12, the 2 that they share, times the 2 from the 4, times the 3 from the 6. And then I would have to take the x squared from the 6. I always take the biggest exponent I can of any variable. If I were to add an a in here, I would have to add that to my least common denominator, okay? Let's go ahead and get started. And I'm going to start with some very simple examples, and then we'll work our way up, okay? So this is an example straight off of your Alex assignment, and it's asking you to subtract. So I'm going to go ahead and I'm going to use my highlighters as much as possible to help me out. And I just got to remind myself that I am subtracting. Now, remember how we practiced looking at the denominator in the last one, but these denominators are not the same. These denominators are totally different. One is a variable, the letter x, and one of them is a number, 5. And so when I have a least common denominator that is that are totally different. They share absolutely nothing. I just go ahead and I make the least common denominator be their multiplication. So let me go ahead and grab a different color. And my LCD is going to be the x from the first denominator times the 5 from the second denominator. Now we commonly would write that as 5x, right? The 5 is coming from the peach, and the x is coming from the yellow. So now I'm going to go ahead and I'm going to change my two rational expressions. So I'm going to use my highlighter to help me out. Since the first rational expression has the orange or has the yellow, I'm going to multiply by that peachy orange color. And since the second one has the peach, I'm going to multiply by the yellow. So now I can come in and I can add the numbers, and I can see them very easy. In the peach is the 5, so it's going to go top and bottom, and I'm going to multiply 3 times 5, and I'm going to multiply 5 times x, top times top, bottom times bottom. And over here, my yellow should be x and x. So I just basically, I have to make this become the denominator, and so I have to multiply by the one that they don't have. And what I do to the bottom of any fraction, I have to do the top, and the same is true on a rational expression because they act much like fractions. All right, so in the numerator of my first rational expression, I have 5 times 3, and in the denominator, I have my LCD of 5x. I'm going to go ahead and subtract like I have in the pink, and on the top of my second rational expression, I have 2 times x, and on the bottom, I have 5x. I'm going to go ahead and clean this up and make it into one rational expression. 5 times 3 is 15 minus, and 2 times x is 2x. There's no need to put it in parentheses because there's no plus, right? Remember we talked about whenever we see minus, we need to put it in parentheses, but I don't see a plus and I don't see a minus after this or before it. So it's just going to go like this, minus 2x all over 5x. The last thing you want to check before you say you're done and this is your answer, take a look at the numerator because there's nothing we can do to the denominator. We've already done what we could. Is there a number that divides into 15 and 2? Well, 2 is a prime number, so the only numbers that divide into 2 are 2 and 1. It's two factors. But 15 is not even, so I can't divide 15 by 2. I'm going to get a decimal. We're done. Oops. And this is our answer. All right, let's go ahead and look at our next example. They're just going to progressively get a little bit harder. Take a look at your denominators. There we go. And we are once again being asked to subtract. So just to help myself remember. All right, so my denominators, I want to look to see, is there anything that they have in common? Is there anything that they have in common? So let's go ahead and grab this. I'm going to say 2y, I can think of it as 2 times y. And 7y, I can think of it as 7 times y. They both have a y. I'm going to make it as dark as I can. There we go. They both have a y. So I don't have to say 2 times y times 7 times y. I only need that y that they share once. I only need the y that they share once. So my LCD is going to be the 2 times the 7 times the y that they share. I only take what they have in common once. Sometimes it's nice to circle what they have in common. That might not be a bad idea. Let's circle what they have in common, and we only take it once. 2 times 7 is 14, so my LCD is 14y. But it's nice to think of it in its multiplication form because this is going to help me when I come up here and I have to decide what am I going to multiply this rational expression by and what am I going to multiply that rational expression by. All right, let's go ahead and do our multiplication. All right, so take a look at the denominator. It has the 2, it has the y. I need to multiply by 7 to make it be 14y. So I'm going to multiply the bottom by 7, which means I multiply the top by 7. Let's take a look at the next one. Let's take a look at the next one. I see 7y, so I have 7, I have y, I need to multiply by 2 to get the 14y. What I do to the bottom, I do to the top. Now what I want to show you with my highlighter is the 7 came from the peach factor and the 2 came from the yellow. But because I already have the y, I don't need it again. And so I just kind of ignored that. All right, here we go. And I'm not sure how much space I have, but here we go. I'm going to make it 14y on the bottom, and I'm going to have 7 times the numerator of y plus 4. Minus 14y, and I'm going to have y minus 5 times 2. I have to go ahead next and distribute both my numerators for both of my numerators. So the 7 times the y and the 7 times 4. So this is going to become 7y plus 28. And then here I'm going to multiply the 2, so I'm going to get 2y minus 10. But don't forget that we are subtracting. So I have to distribute this subtraction to the 2y and to the minus 10, which is going to change that minus 10 to plus 10. So I just have to remember that when I go on to my next step. All right, here's my next step. I'm going to combine it all into one big fraction. So 7y plus 28 for my distributing of my first rational numerator. Then I'm going to subtract this, but remember that means I'm distributing it. That means I'm distributing it. So minus 2y plus 10. Okay, now I'm going to go ahead and I'm going to combine together my like terms. And I think I'm getting close to my next example. Yep, there we go. My next step is to take a look at my numerator. There are 4 terms, 1, 2, 3, 4, and I'm going to go ahead and add together my like terms. I'm going to combine my like terms. The 7y minus the 2y, that's going to become 5y. And the positive 28 plus the 10 is going to become plus 38. And then just like I did in the last one, I want to see, is there a number that divides into both 5 and 38? Like, could we divide 14 in there? Could we divide it by 2? Could we divide it by 7? No, 5 divided by 2 is a fraction. 5 divided by 7 is a fraction. And so I'm not even going to check the 38. This is my final answer. All right, my next example is a U-try. And if you were in class today, we actually put this one in the Padlet, but I'm going to go over it super fast. So take a look at our denominators. Just like the last one, they are sharing a D. They are sharing a D, and I don't know why, but I got a bunch of subtractions when I did this one. So just like before, let's grab our LCD. 7D I can think of as 7 times D. And 2D I can think of as 2 times D. Very similar to the last one. So my least common denominator is going to be the 7 times the 2 times the D that they share. Because remember, they're sharing this. It's shared, so it only comes into the denominator once. And 7 times 2 is 14, and D. So really, I have the same exact problem we just did. We're just changing the numerators is really what's going on here. All right, so let's go ahead and look. This one needs to be multiplied. I have the 7, I have the D, I need the 2 to get to 14. So I'm going to multiply by 2, multiply by 2. And once again, that 2 is coming from the other denominator, from the peach. All right, let's take a look at this one. I have 2D, I need this. So 2's gone, D's gone. I need the 7 to get to the 14. Put it on the bottom, then put it on the top. And once again, just take a look here quick. The 7 is coming from the yellow factor. All right, so in the first one, I have 2 times 9, and I have my 14D minus 1 times 7 and my 14D. All I have to do is go ahead and multiply 18 minus 7 over 14D, and then 18 minus 7, I know what that is. I'm going to put it down here. That would be 11 over 14D. The last thing I would have to check is 11 over 14. Does it reduce anymore? Does it simplify? No, it does not. There's my answer. All right, let's go ahead and add in some variables. What's going to happen when we start adding more and more variables to our denominators? So here is my first denominator, and here is my second denominator. I'm going to go ahead and I'm going to take a look at each one separately. Okay, so I can think of this as 2, and then the w squared, I can think of it as being 2 w's. The 5w cubed, I can think of it as 5, and then the w cubed as 3 w's. So remember, the numbers and the variables, we take what they have in common only once. So for my LCD, I'm only going to take what they have in common once. So they have 1, 2, right? They have 2 sets in common. Okay, so really it's like they have this in common and they have this in common. But notice I have this extra W, it's got to go too. So I've got 2 times 5 times, I've got to take all 3 W's. I take the 2 they have in common, plus I got to take that extra one from the second. So 2 times 5 is 10, and W times W times W is W cubed. I'm just making sure I had enough W's. All right, let's go ahead and take a look at what we need to multiply each side by. So remember, you're just looking at what you have and you can cross it out. I need a 5 and I need a W to get to the 10W cubed. So I need a 5 and I need a W. What I do to the bottom, I have to do to the top. Let's take a look at our second one. I have the 5 and I have all 3 W's. I just need the 2 to get to the 10W cubed. Okay, and once again, notice that this is coming from the peach and this is coming from the yellow. Okay, but you have to be a little bit careful when you also have the variables. And so I think it's a very good idea to come over here and look at it in its factored form and just start crossing out. Like from our first one, then it's very easy to see what you need to get to here, what you need to get to there. All right, let's go ahead and start multiplying then. All right, I've got 10W cubed on the bottom and I have 5W times 7. I can go ahead and multiply. Oh, I forgot to remind myself that I was subtracting. I had to go and look. It is okay. You're going to have to multiply the 5 times the 7. You can do that. That's exactly going to be our next step if that's what you were thinking. And 2 times 2 is 4. So I'm going to go ahead and I'm going to multiply. 5 times 7 is 35. W minus 4 over 10W cubed. The last thing you want to do is just to check to see, is there a number that divides into both of these that is also a factor of 10? So 10 would be 2 times 5, and so it'd have to be 2 or it would have to be 5. Well, this is 5 times 7, and this one is 2 times 2, but I don't see a common here where I can divide both of them by 2 or both of them by 5. So this is my final answer. This is my final answer. All right, let me see. I'm not sure. I think that's it for that page. All right, I've got one last example. And the only reason for this last example, take a look at your denominators. And there's a b cubed. And then here I have a b squared and a k. Ooh, this is going to be tricky. And then finally, we can add. We're just going to go ahead and add together here. All right, let's go ahead and take a look at our LCD. Let's take a look at 12ab to the third. So I'm going to break 12 down into its prime factors. So I can think of 12 as 2 times 6, but I can think of 6 as 2 times 3. And so I want it in this combination of 2s and 3s and 5s and 7s and 11s and maybe 13 if I'm going to get crazy. Then I'm going to have an A, and then I'm going to have 1, 2, 3 B's. Okay, 8. Let's think of 8. Okay, let's think of 8, and then we'll worry about the variables. So 8 I can think of as 2 times 4, and 4 I can think of as 2 times 2. Then I would have 2 b's, and I would have a k. All right, I need to go ahead and I need to look at what do they have in common. Well, they both share a 2 at the very beginning, and then they both share a second 2 at the very beginning. So these two 2's and these two 2's are only going to go into the LCD once. So I'm going to say LCD is 2 times 2. What does the 12 still have? Well, the 12 still has a 3. And what does the 8 still have? Well, the 8 still has a 2. Okay, so 2 times 2 times 3 times 2. Or I have 4, right? This would be 4 times 6, 24. There's the number that I have. But I can also think of it as 2 times 2 times 3 times 6. Or 2 times 2 times 3 times 2, or 4 times 6. Now let's go ahead and look at our letters. There's an A, so the A's got to come down. How many B's do they have in common? Well, they have one set of B's, they have two set of B's, and then there's a third B. So I've got to do all three B's, and then there's a K. Now, most of the time with your variables, with the letters, they're going to go in alphabetical order. That's just proper. That's just what we've all kind of agreed on in math. But there's really no reason to it that I'm aware of. So it shouldn't be a big deal if you have the K first and then the A and the B. It shouldn't matter. But there it is. There is our LCD. Let's go ahead and figure out what we need to multiply both sides by. Okay, so we have a 12. We have a 12, so here we go. Well, here's 12 right here. So 2, 2, and 3 is gone. There's an A, and there's 1, 2, 3 B's. So notice what's left. I need a 2, and I need a K to get to this denominator. So I'm going to put 2K, and what I put on the bottom, I put on the top. All right, 8, 8. There's 8 right there. Cross them out. One, bum, bum. I need the 3. I need to get rid of 2 B's, and I need to get rid of a K. So notice what's left. I need a 3, I need an A, and I need a B to get to my new denominator, 3AB. 3AB. What I do to the bottom, I do to the top. Now take a look. These are still coming from the other one. These are still coming from what's left, right? This is what's coming from what's left in my 8, and this is what's coming from what was left in my 12, right? These are coming from each other. And if you look, look at this right here. 2K, 2K. What? 3AB, 3AB. Oh my gosh, that is so cool. There they are. There's what I need to multiply by. All right, let's go ahead and actually do this multiplication. So I'm going to have 24 AB to the third, K on the bottom, and on the top I'm going to have 2K times K to the third, X to the third. Plus, we finally get to do a plus. I have my 24AB to the third, K on the bottom, 3V squared times 3AB. Now, there's really no reason as to which one goes first. I'm just putting it in order from left to right. So that's why I put this one times this one for this rational, and that's why I put this one times that one for this rational. There's really no rhyme or reason to it. I'm just going in order. Now I'm going to go ahead and I'm going to make them into one rational expression all over my least common denominator. All right, so in my first numerator, there is no number to multiply. There's just a 2, so I'm going to keep my 2. But notice I have a k here and I have 3 k's here. So I'm going to have this 1k and I'm going to add to it the 3 k's. That's going to give me 4 k's, and then the x third stays. In my second denominator, I am going to go ahead and multiply 3 times 3. And then since all of my variables are different, I'm just going to go ahead and put them in alphabetical order. So 3 times 3 is 9, a, b, v squared. Now, what I'm going to look for here is, can I factor anything out that will cancel? I could cancel a 2 here, but I cannot cancel a 2 here. 9 is not an even number. Um, I have a new variable on the top. In fact, I have 2 new variables on the top. So I'm going to go ahead and say this is my final answer.